Okay, now we have, well, we have an x squared and a y squared. So that tells us it's some kind of hyperbola. And since we're in ellipsis, we can assume it's an ellipse. But what we have to do here is, because I have a y squared and a y term, I'm going to complete the square on y. Okay, and I'm going to kind of ignore the x squared. No, actually, I'm going to get rid of it. I'm just going to move the x squared and the number over to the other side. And that'll give me y squared minus 6y equals negative 16x squared plus 7. And I'm going to ignore the stuff on the right-hand side because I'm going to complete the square on the left-hand side. And remember, to complete the square, I'm going to have to add b over 2 squared. So here, that's a negative 6 over 2. I like to see the negative 3 because I'm going to use that in the binomial. So I'm going to add 9 to both sides. Now, here's the thing. Actually, this won't be too bad here. So I get y squared minus 6y plus 9 equals negative 16x squared plus 16. I'm going to rewrite that as y minus 3 all squared. That's why I like to hang on to that negative 3. And I'm going to also move over the 16x squared. The reason I'm moving that over and not the 16 is I need a number 1 on the right-hand side for my standard form. So that gives plus 16x squared equals 16. So now what I'm aiming at is I need a 1 on the right-hand side. So I'm going to divide everything by 16 to get the 1 on the right-hand side to make it sure it's in standard form. That gives you y minus 3 squared divided by 16, and that just leaves me the x squared. And I'm going to put that over 1 to make it a fraction, and that's equal to 1. So putting it in standard form so I can see all my transformations. My major axis is the y-axis. Minor axis is the x-axis. And this transformation here says the whole thing moves up 3. All right, let's go to XYZ and clear the last one. So I have my origin is moving up 3. So I'm going to put my point there. And then the y-axis is the major axis. And so I want to make sure that's 4. And x is 1. So it looks like there's my ellipse. Moved up 3. Major axis is 4 by 4. Minor axis is 1 by 1. Okay, I think I'm going to stop this video and, no, let's try the next one. Okay. It's just going to take a while, so this one's going to be a little bit long. All right, so what's happening here is similar to the last problem, but notice I have an x squared and an x, and a y squared and a y. So I have to complete the square on both x squared and y squared. I'm going to do that one at a time. Let's see what I got here. After I'm moving the constant over just to get it out of the way. And what I can do is I'm going to factor each pair. I'm going to factor the x squared pair and I'm going to factor the y squared pair. Because when you complete the square, it has to be on one x squared or y squared. Sorry, that's 2y there. Okay, completing the square on x squared, my b is 6. I'm going to add 9 to both sides. Now, here's the tricky thing. I'm adding a 9 and it needs to go inside those parentheses. So on the right-hand side, I'm going to have to add 9 times 9. I'm taking the 9 on the outside because essentially I'm adding 81. When I put a 9 on the inside of those parentheses, I have to add an 81. I just don't want to show that factoring work. Okay, so I get 9 times x squared plus 6x plus 9. Okay, now I'm going to work on squaring the y squared. So on this one, I get my b is a negative 2 over 2, which gives a negative 1 squared, which is 1. So similarly, I'm going to add 1 to both sides, but on the right-hand side, it's going to be 16 times 1. So I'm essentially adding a 16. All right, that allows me to write the y squared as y squared minus 2y plus 1 equals 47 plus 81 plus 16, which is going to give me a 144. Okay, so now I have 9 times x plus 3 all squared. I can write those as binomials, plus 16 y minus 1 squared equals 144. Last thing I have to do is get rid of these two multipliers in front of my x squared and y squared binomials. So what I'm going to do is I'm just going to divide the whole darn thing by 9. And that gives me x plus 3 squared plus 16 y minus 1 squared over 9. And 144 divided by 9, turns out it's 16. Super convenient number, because the next thing I'm going to do is divide everything by 16 so I can get rid of that multiplier. All right, that's going to look like x plus 3 squared over 16 plus, I need just a little more room. Okay, plus the 16s cancel. I get y minus 1 squared over 9. And 16 divided by 16. Wow, that worked out really nice. Yeah, they usually will. All right, so I'm going to just take a moment to rewrite my denominators as numbers squared. And that means that the major axis is along the x orientation. And my minor axis is on the y. And my transformation is going to be left 3, and it looks like up 1. I'm going to graph this first because it's going to be easier to answer the questions by looking at the graph. Okay, so on this one, we're going left 3 and up 1. So there's the center of my ellipse. And it's the major axis is along the x, so I'm going to move 4 away from that center. And y is 3. And there's my ellipse. And it looks like the major axis points are -7, +1, and 1, 1. Minor axis, it looks like it's these 2 points, at -3, +4, -3, -2. And then the foci is going to be along the x-axis, and so my y-coordinate there is 1. And I'm going to calculate the foci, which is c equals the square root of 4 squared minus 3 squared. So that looks like it's the square root of 7. So negative, okay. But this is square root of 7 away. Yep. So let's take a look at the graph. So what I have is the, so if my center's here and at -3, so I have -3, wait, I'm moving square root of 7 away from these 2 points. So I have -7 minus the square root of 7 and 1 minus the square root of 7. So I didn't give myself enough room. -7 minus square root of 7 is my x-coordinate, and 1 minus square root of 7, actually 1 minus square root of 7, now I better leave it like that. I figured I could do 1 and I lost the minus sign. It will accept those answers. And that got kind of complicated on the foci. All right, done with this. See you on the next one.